In the question number 41, the velocity of sound in dry air is Vd and in moist air is Vm if velocities are measured under the same conditions of temperature and pressure. Then, in this question, I would like to say only one thing: density of moist air is less than that of dry air. And in terms of formula, we will write like that: V inversely proportional to root of density. So my third option will be the right choice. We'll move question number 42. In the question number 42, mark the incorrect statement. So before going to take the option, as I said earlier, I would like to explain few points. Number 1, pressure variation is maximum at nodes. We know. And number 2, for stationary wave, you know very well, all particles oscillate in same phase. Number 1, within loop में होते हैं. Stationary wave is formed when two waves are traveling in opposite directions. So this is the basic knowledge. Now I am going to read the options. So when you will reach the option number 4, you will get stationary wave can be produced when superimposed waves are moving in the same direction. So my option number 4 will be the right choice. So we'll move question number 43. Question number 43. At time t equal to 0, a transverse wave pulse in a wire is represented by y is equal to 10 upon x square plus 4, where x and y in meter, the function of y position and time that describe the wave equation traveling in negative x direction with a speed of 5 meter per second. So before going to find the option, I would like to say the equation can be written as function of position plus minus Vt, right? And if I go the solution, then first I will y is equal to f of the function x plus Vt I will take. But when wave is moving towards negative x-axis, then I will use this function. But the another one, fx minus of Vt, when wave is moving towards positive x-axis, so I will use this. So you will concentrate x plus Vt. Here V is 5 meter per second, right? So now I am going to find my options. If I go for first 10 upon x plus 5t, speed is 5, yes, and plus 4, right? And question is asking to us, describe the wave equation traveling in negative x direction. Negative means x plus Vt. The first option will be the right choice. So let's move on. Question number 44. Question number 44. A particle of mass 2 kg moving along x-axis under the action of force this. So I can compare this by minus kx, and we know k is equal to m omega square. Now I am going to read another part of the question. F in Newton, x in meter, time period of oscillation. So by this relation, if I go for omega, will write k upon m with the root, right? Or omega square is equal to k upon m. So I need the value of k for the time period. So you know, if I compare with this equation, then easily you can find the value of k is pi square by 4. Because this is the value, if I compare this, because this is the formula of restoring force. So I can use this. So if I use the given value, we'll write pi square by 4 in place of k. Mass is given 2 kg. So we'll get pi square by 8, right? And omega is equal to pi upon 2 root 2, right? And you know, you will write in place of omega 2 pi upon t. So pi upon 2 root 2. Pi will cancel. If I go for the time period, then we'll get time period is equal to 4 root 2 second. So my option number 1 will be the right choice. We'll move question number 45. In the question number 45, 2 kg block connected with 2 massless spring as shown in figure is executing simple harmonic motion then time period of block is, so you know the time period is T is equal to 2 pi m by k. Mass and k is the spring constant, right? And you know, if two springs are connected in parallel, then we can take effective spring constant K1 plus K2. And how you know if they are connected in parallel or not? So you can compare with the capacitor. So here, if I consider this spring is capacitor number 1 and this is capacitor number 2, then you are saying that they are not connected directly. On the other hand, you can understand they are not following the rule of series combination of the capacitor. So they will be in parallel. So I can write the effective spring constant will be K1 plus K2. Right? Now, if I go for time period 2 pi, mass is 2 kg and K will be, because K1 is 100, K2 is 200, so it will become 300. So final answer will be 2 pi upon root of 150 second. So this is how you can solve. So my option number 2 will be the right choice. So thank you very much and we'll meet again in the next AITS. Thank you.